Now we're going to start doing word problems in this chapter, and many people are afraid of word problems, but there's really no reason to be afraid of them. You're going to find that they're relatively easy to do if you approach them in a methodical manner, and that's what I'm going to help you do right now. The first thing to do when you're doing a word problem is read through the problem and find every number and set it equal to a variable. After reading through the problem, you're going to want to say to yourself, what equation governs this problem? So you write that equation down. The next thing, identify what variable is being asked for to being solved. Meaning, if it says, what is the new volume, then you know you're going to be having to solve for V2. So you solve for that variable before putting any numbers into your equation. It has been shown that students will make fewer mistakes if they rearrange their equation prior to putting numbers in for the variable. After you've solved for that variable and you found that V2 is equal to P1 V1 over P2, let's say, well, then you substitute the numbers in for those variables and then use your calculator to chug out an answer. I call this step the plug and chug. Remember, in putting your numbers into the formulas, make sure every number has a unit. By looking at unit cancellation, you can check to make sure that you've done your equation rearrangement properly. Here is an example. A party balloon is filled to a volume of 4.5 liters with helium at a location near sea level, where the atmospheric pressure is measured at 748 torr. Assuming that the temperature remains constant, what will be the volume of the balloon when it is taken to a mountain resort at 2,500 meters, where the atmospheric pressure is 557 torr? Okay, let's go through, and what we first want to do is take each number that's in this equation and set it equal to a variable. 4.5 liters. Well, that's volume. 748 torr. The unit torr tells me that's pressure. 2,500 meters. Well, that's altitude. Oh, wait, we haven't covered altitude, have we? So most likely, you won't need it. 557 torr. What is that? Well, the torr tells me it's pressure. I know that there's initial conditions, so 4.50 liter and 748 torr are my V1 and my P1. And then I have final conditions, 557 torr. So in our next step now is to identify what we're solving for. If you look at the question, it says, what will be the volume? And you know you already have V1, so this must be V2 that you have to solve for. Or you could have said volume, and it's considering it under new conditions, so then you would say, okay, it's V2. So you can actually write it like this as an equation, question mark equals V2, to help yourself know what you need to solve. Next thing is to identify which equation applies. this is all that we have so far, the only equation that we can use, so we're going to use this. With time, though, I'm going to show you how do you identify whether it's this equation or another you might use. So I look at this equation and I look to see, is there anything that I can take out of this to simplify it, something that might be held constant. Well, if I look at this balloon, I'm taking it from a location near sea level to a mountain resort, and it doesn't say anything's being lost or gained by the balloon, so I can safely assume that the number of moles is staying the same. Likewise, it says assuming that the temperature remains constant. Well, that means that my temperature is staying constant and it will drop out of the equation. So both N and T drop out of the equation, and it simplifies it to this: P1 V1 equals P2 V2. Now I need to solve for V2, so I rearrange my equation so that it says P1 V1 over P2 is equal to P2. Remember, rearrange your equation before plugging any numbers in. It's much more likely to give you answers without mistakes. Now that I have my setup, I have my unknown being solved equal to some variables, this is the point at which we plug and chug for our answer. So now what do? Is I plug in the numbers that I have for the variables. Okay, 748 torrs P1, 4.5 liters is V1, and 557 torrs P2, and then I do math and I chug out an answer on my calculator, and that gives me 6.04 liters. Now what I'd like you to do is, using the same principles that we've just learned, pause, do this problem, and then press resume when you're finished. Okay, to do this problem, the first thing that you're going to have to do is go through the problem and find each one of the variables and set it equal to, each one of the numbers and set it equal to a variable. We come up with 27 degrees Celsius. Well, we're going to call that T1. And we have volume 2 liters, so I say V1 equals 2 liters. Where's the temperature? Where the temperature is negative 23 degrees Celsius, well, that's my T2. Notice I've changed them all to Kelvin because the gas laws do not apply unless you use Kelvin. The next thing I'm going to do is I'm going to write the equation that applies. The equation that applies is this. Now remember, what are we solving for? It says what will be the volume outdoors, so we know we're going to be solving for V2. So I look at this equation and I say, what can I drop out of this equation, if anything? It says assume pressure does not change, so I know that P1 and P2 will drop out, and the balloon is not being described as losing or gaining molecules, so both P1 N1, P2 and N2 will drop out of this equation, so I rewrite it like this. Now, V2 is what I need to solve for. So I'm going to rearrange my equation by multiplying both sides of the equation by V2. Multiplying both sides of the equation by V2 gives V2 all by itself, which is what you need to solve for it. It also gives you that V2 is equal to T2 V1 over T1. Now that I've solved for V2, I can go ahead and plug in my values for T1, V1, and T2. I've plugged them into the equation, and then I plug them in my calculator, and I determined that my new volume, my V2, is equal to 1.83. Notice that you can actually guess your answer prior to starting this problem, and it's a good technique, is to notice that I'm taking a balloon from a warmer temperature and taking it to a cooler temperature. You already know that you expect that it should shrink. So you look at your volume that you have coming out of this and you say, is it behaving as I expect it to? And since it is shrinking in volume, then you would say, oh, I probably did it right. Here's another problem for you to try. 2.53 meters cubed at negative 15 degrees Celsius and 191 torr. What will be its new volume when it's occupying, what new volume will it occupy when it is at 25 degrees Celsius and 1,142 torr? Okay, to do this, we go ahead and we take each one of the numbers and set it equal to a variable. So meters cubed is volume, negative 15 degrees Celsius is temperature, but we know we must convert it to Kelvin. 191 torr, that's a pressure, so that's my P1. And then 25 degrees Celsius must be my T2. And then 1,142 torr is my P2. I next ask myself, the equation that applies now is P1V1 over N1T1 equals P2V2 over N2T2. The first thing that I see about this equation is that I don't have N2 or N1 in any of my variables that I have gotten from numbers from the problem. If I read through the problem, I can see that they're not talking about the number of gas molecules increasing or decreasing. So I can safely drop the number of moles, N1 and N2, from this equation. That gives me this simplified equation. Now I'm going to be solving for what volume will it occupy. That's going to be V2. To solve for V2, I need to get rid of what's being multiplied or divided into it. So P2 is multiplying by V2 and T2 is dividing into V2. I need to get rid of those two variables. How do I do that? Well, P2 is multiplying by V2, so I must divide by P2. And T2 is dividing into V2, so I must multiply by T2. So I'm showing that on this right side of the equation, you can see there's the P2 V2 over T2, but now I've multiplied by T2 and I've divided by P2. If I do that to the right-hand side of the equation, I must also do it to the left-hand side of the equation. So now on the left-hand side of the equation where we had P1 V1 over T1, we also now have T2 multiplying by that and P2 dividing into it. If I look at the right-hand side of the equation, you can see that P2 divided by P2 cancels out, and T2 divided by T2 cancels out, so we get V2 is equal to T2 P1 V1 over P2 T1. I've done all the hard work now. The only thing that I need to do is to plug all my numbers in for my variables. So I go ahead and I plug those numbers in for my variables, and I see that I get 298 Kelvin times 191 torr times 253 meters cubed divided by 1,142 torr divided by 258 Kelvin. Notice my kelvins cancel out, my torrs cancel out, and I get meters cubed as my answer, and that is a volume. Always check to make sure that your units are working. If I go ahead and plug these numbers into the calculator, you'll see that this answer is then 0.489 meters cubed.